Hey you guys, this is Mr. Millings, and in this video we are going to be taking a look at some more advanced Boyle's Law calculations. So let's jump right in and take a look at an example problem. In this example problem, it says a sample of gas is placed in a flexible spherical container that has a radius of 97.2 centimeters and an initial pressure of 10.9 millimeters of mercury. If the pressure of the gas inside the container is changed to 18.2 psi, then what will the new volume of the gas in the container be in liters? And we can assume constant temperature. So if we take a look at this problem, we have a spherical container here, and this spherical container is flexible. And so if we read this question here, it also tells us that the radius of this spherical container here is equal to 97.2 centimeters. And inside of this spherical container, we have some sort of gas. So we have a gas. Here are some gas particles that are inside of this flexible spherical container. And what we know is that initially the pressure of the gas that is in this container, or P1, is 10.9 millimeters of mercury. And so what's happening is that the pressure of the gas inside this container is changing to 18.2 psi. So pressure 2 is 18.2 psi. What this question is asking is for us to calculate what the new volume, so V2 is what we're trying to figure out. We're trying to figure out the new volume of the container in liters. So we have a container, this spherical container here, which is flexible. We know that inside of this spherical container we have a gas, and initially that gas is exerting 10.9 millimeters of mercury of pressure. We also know that the radius of this spherical container is 97.2 centimeters. And so what's going to end up happening is that the pressure of the gas that is in this container is going to change to 18.2 psi. What we're asked to figure out is the final volume of the gas that is in this container. So what we have to figure out first is the initial volume in liters of the gas that's in this container. So how can we do that? How can we figure out the initial volume of the gas that's in this container? Well, if we take a look, we know that the radius of this sphere is 97.2 centimeters. We also know that the volume of a sphere is equal to 4/3 times pi times r cubed. So if we take a look, we can figure out what the volume of this sphere is. If we figure out the volume of the sphere is, that's going to be our initial volume of the gas that is in this spherical container. So let's go ahead and figure out what the volume of this sphere is. We're going to take 4/3 times pi times the radius, which it tells us right here is 97.2 centimeters. And we're going to cube that. And so when we put this in our calculator, when we take 4 times pi times 97.2 cubed, and then divide by 3, we are going to end up with 3.85 times 10 to the 6th. 3.85 times 10 to the 6th centimeters cubed, which is the same thing as 3.85 times 10 to the 6th milliliters. Centimeters cubed and milliliters are used interchangeably, but we want the volume in liters here. So how can we convert this into liters? Well, if we take a look here, we have 3.85 times 10 to the 6th milliliters is our initial volume of this container. We want to cancel out milliliters and convert to liters. We know that 1 liter is 1,000 milliliters. So when we take 3.85 times 10 to the 6th and we divide it by 3, we are going to end up with, let's take a look here. We're going to take 3.85 times 10 to the 6th and we're going to divide this by 1,000. Sorry about that. We're going to divide by 1,000. We are going to end up with 3,850. So we are going to end up with 3,850 liters. So we just figured out what V1 is. If we take a look here, V1 is going to equal 3,850 liters. 3,850 liters is V1. And so what we're asked to figure out now is what V2 is. Well, we know that Boyle's law states that P1 times V1, the initial pressure times the initial volume of the gas, is going to equal the final pressure times the final volume of our gas, or P2V2. So P1 times V1 equals P2 times V2, and in this problem we're asked to figure out the new volume of our gas. So we want to solve for V2. We'll have to divide both sides by P2 here. P2 is now going to cancel, and the formula that we're going to use to solve this problem is going to end up being V2 equaling P1 times V1 all over P2. So what is P1? Well, it tells us that P1 is 10.9 millimeters of mercury, but if we take a look, P2 is in PSI. So we either have to convert this to PSI or convert this to millimeters of mercury, and it doesn't really matter which one we convert to. We can arbitrarily pick for this question. So let's go ahead and convert P2 to millimeters of mercury. We see that P2 equals 18.2 PSI. We want to cancel out PSI and we want to figure out how many millimeters of mercury this is. So if we take a look at a conversion factor table, we can see that for every 760 millimeters of mercury, there's 14.69 PSI. And so this will cancel with this, so we take 18.2 times 760, and we're going to divide this by 14.69, and we're going to end up with 942 millimeters of mercury. So this isn't our final answer, this is just P2. So we now have P2 in millimeters of mercury. So now that we have both pressure units the same, we can go ahead and work on this calculation. So P1 is 10.9 millimeters of mercury, 10.9 millimeters of mercury, times V1, if we take a look, is 3,850 liters. And we're going to divide this by P2, which is 942 millimeters of mercury. And so when we take 10.9 times 3,850 and then we divide that by 942, we are going to end up with 44.5. 44.5 what? Well, millimeters of mercury on top and bottom cancel, leaving us with liters. So we just figured out what the final volume of this container is going to be. If the pressure initially inside of this container was 10.9 millimeters of mercury, and that pressure increased to 942 millimeters of mercury, according to Boyle's law, pressure and volume are inversely proportional. So if we take a look here, what is happening to the pressure? The pressure is going from 10.9 millimeters of mercury to 942 millimeters of mercury. So the pressure is increasing here. Therefore, the volume should be decreasing of this container. And in fact, if we take a look here, we can see that the initial volume was 3,850 liters. And so the final volume of this container here is going to look something like this. It's going to end up being 44.5 liters. The initial volume was 3,850 liters. And so does that answer make sense? It appears to make sense. If we take a look, our final pressure is about 90 times the initial pressure. Therefore, if we take a look here, our final volume here should be about 1/90th approximately the initial volume. And in fact, that's the case. 44.5 liters is about 1/90th the volume of our initial volume here. So our answer makes sense. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner. That will subscribe you to my channel, and feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.